Okay guys, welcome to class. This is my first time recording in my classroom, so if I'm like only half in the frame and it's like chopping my forehead off or whatever, we're just gonna have to deal with it and we'll fix it for the next one, okay? So, welcome to class today. We're gonna accomplish three main tasks during this video. The first one is to answer this question: what is air pressure? The second one, how do we actually measure the amount of pressure in the air? And the last one, how does it affect the weather? Why does it make it sunny outside? Why does it make it cloudy outside? So we're going to attempt to do that right here on this piece of the board. So let's start right here. Just by using the words air pressure, obviously we know it's air molecules, and they somehow exert pressure on us and on the table and on this board and on anything they touch. And so what I want you to do is just think about it. There's molecules in the air right now, right? And they are zooming around. And then since they're zooming around, they must be running into me. Now, when they run into me, that generates a force. Now, it's not enough for me to feel and notice, but it's enough to push in on me constantly. That's what we call air pressure. It's really just the force exerted by air when it runs into something. And since there's lots of molecules here, they're running into me constantly, and they're pushing in on me, they're pushing down on me, whichever way they run into. And they exert that force on anything they touch. So that's what air pressure is in general. Now, if you look at my picture up here, hopefully you can see it. Over here in my high pressure area, I have lots of air molecules, little blue dots. Since there's more molecules, they're gonna push on you, that's you, they're gonna push on you more because there's more air molecules. That's what a high pressure center is. It just means there's a high density of air molecules. Now the low pressure center over here, low air pressure, you'll see there's a lot less air molecules. That means there's a low density of air molecules, and they're hitting you less often, so it exerts less pressure. Higher pressure, lower pressure. It all has to do with how many molecules are there. That's what air pressure is. Now, how you measure it, there's lots of different ways to do it, but the device we use is called a barometer, spelled barometer, barometer. Now the original one is kind of like what's in your notes and what I drew right here. We have better technologically advanced ones now, but this one's kind of simple and I think it'll make sense to you. They started with a bowl of mercury, which is really cool liquid metal. All right, and this is back in the 1600s. In this bowl of mercury, they would take a big test tube and they'd fill it with mercury and then they would invert it. So the opening of the test tube's down here at the bottom. And what would happen is there's mercury all the way up to, let's just say right here. Right? And up here, it creates what's called a vacuum. Now, when there's higher pressure, remember there's molecules pushing on things, in high pressure times, the air pushes on this mercury and forces it up the tube. And when it forces up the tube, it rises up higher. That's why we call it high pressure. And the opposite is true when it's lower pressure. It pushes on it less, and so instead of going up, it now goes down, back into the bowl, and my level of mercury in the tube will drop down. Now, back when Torricelli invented this thing, back in the 1600s, which was by accident, by the way, random side note, he had it, he had it set up in his lab, and what he noticed is every time there was a storm or it rained, the mercury was really low in his barometer. Every time it was sunny, the mercury was really high. And there was a distinct correlation there that he connected, which leads us to our last thing, which, how does air pressure affect the weather? And I know you'll be impressed, but you might even be able to hear the bird clock going off. Anyway, I'm going to talk through it. So in my last picture right here, high pressure, low pressure. You can see high pressure, we already said, is high density of air. Now, I don't know if you remember convection from Earth science. Do you remember what less dense things do? Less dense fluids always go up. So air is no different. If it's less dense, it's going up. That means more dense has to be going down. Now, my more dense air, as it goes down, hits the ground. These are air molecules. They have to go somewhere, so they get shoved sideways and then brought back up. And does that look like our convection currents? So what we find in the atmosphere is there are convection currents going on between high and low pressure centers. And for whatever it's worth, let's pretend this is you. What's it feel like if there's air molecules flowing past you? That's the wind. Okay? Wind takes place out on Earth's surface when air is going from a high to a low pressure center. It's going from high concentration to low concentration, which, if you remember from biology last year, is just an example of diffusion.
At this time, Mr. Shaw's class, Mrs. Roberts' class, and Mr. Gray's class can be released for lunch. I will release PM Career Center at 10:30. Thank you.
Don't mind that. So, we still have to go back to how does it affect the weather? I see that in a high pressure center the air is sinking because it's more dense. I can see it's rising because it's less dense, but why would that make it sunny or cloudy? So here's what you need to know. In high pressure areas, it is typically sunny. In low pressure areas, it's typically cloudy. And here's why. To get a cloud, you have to have water vapor in the air, and that water vapor has to go up. Which scenario has water vapor going up? Well, this one right here. So here's my water vapor, and as the water vapor goes up with the air, it gets cold and forms clouds. So let me say it again. In a low pressure center, the air is less dense. Less dense air has to rise. Since water vapor is part of that less dense air, the water vapor is going up also. Water vapor, though, as it goes up, gets cold, and it condenses into a cloud. Excuse me. Contrast that with our high pressure center. In a high pressure center, the air is more dense. When air is more dense, it has to sink. Now, if the air is sinking, water vapor is part of the air. So that means the water vapor is going down. If it's going down, it can't rise, and it can't cool, and it can't form clouds. As a result, high pressure areas are usually sunny, and low pressure areas are usually cloudy. That's all for today. Hopefully you're having a great day. I'll talk to you again soon.